Good morning students. Today we will have brief introduction to ARM microcontroller. ARM stands for Advanced RISC Machines. The content of this presentations, at the start we will learn what is a microcontroller. We see the difference between microprocessor and microcontroller. Then we will have an introduction to ARM controller, and then we will go for what's its features and why we have to use ARM is. A microcontroller, that is MCU, is a small computer on a single integrated circuit, that is a chip, designed to control specific tasks within a electronic systems. Your CPU, central processing unit of a computer, it can perform multiple tasks. It combines the functions of a CPU, memory, input-output interfaces all in a single chip. Microcontrollers are widely used in embedded systems such as home appliances, automotive systems, medical devices, industrial control systems. They are also used in consumer electronics products such as MP3, gaming, digital cameras, audio players. A typical microcontroller consisting of a processor core, volatile and non-volatile memory, that is RAM and ROM, I/O devices, that is peripherals, and various communication interfaces. The processor core is responsible for executing the instructions and controlling the other components of the microcontroller. Microcontrollers are programmable to perform the specific task because they are developed for a specific task only. Some of the commonly used programming language are C, C++, and assembly level language. Now we will see what is the difference between a microprocessor and microcontroller. A microprocessor is the heart of a computer system and you are referring it as a CPU, that is central processing unit, while microcontroller is the heart of an embedded system. Microprocessor is only a processor, so memory and all I/O components connected externally to the microprocessor with external bus, while microcontroller has a processor, that is a core, along with internal memory and I/O components on a single chip. In a microprocessor, memory and I/O has to be connected externally, so circuit becomes large, while microcontroller, uh, as memory and I/O is already present, so internal circuit is a very small. Microprocessor can't be used in a compact systems. While microcontroller can be used in compact systems, that is why we are using in gaming devices, in manufacturing industry, like in home appliances. Microprocessor is too much costly. um, that is why laptops, computers, its cost is quite high, while microcontroller cost of the entire system is a low. So many external components are connected to the microprocessor through external bus, so total power consumption is of the microprocessor is high. So it is not ideal for the devices that is running on a stored power like batteries. While microcontroller, as all the devices are connected on a single chip, so its external power consumption is less. It can be used in a devices running on a stored power like batteries. Most of the microprocessors do not have power saving feature, while microcontrollers are offer power saving mode. Microprocessor mainly used in computers, laptops, desktops, while microcontrollers mainly used in washing machines, MP3 players, remotes, embedded systems, in manufacturing automation industry. Microprocessor has a smaller number of registers, so more operations are memory based, while microcontroller has a rich set of registers, hence the programs are easier to write and quite faster, and they are using maximum use of registers. They are not directly accessing to the memory. Microprocessors architecture is based on von Neumann model, while microcontrollers architecture is based on Harvard architecture. Microprocessor is a central processing unit on a single silicon based integrated chip. While microcontroller is a byproduct of the development of a microprocessor with a CPU along with other peripherals, microprocessor has no RAM, ROM, I/O units, timers, other peripherals on the chip, while microcontroller has its own CPU along with RAM, ROM, other peripherals embedded in a single chip. Microprocessor based systems can run at very high speed because of the technology involved, while microcontroller based systems can run up to 200 megahertz or more depending on the architecture. This is what the sample diagram of its architecture microprocessor, how all the devices are connected with system bus to the processor, while all the devices, that is volatile, non-volatile memory, IO port, timer, they are connected with microcontroller. Microprocessor used for general purpose applications that allow you to handle the large data, as microcontrollers are very application specific systems. A microcontroller used in washing machine can't be used for any another home appliances. They are application specific. Microprocessors are complex and expensive with a large number of instructions to process. They are CISC architecture, while microcontroller, they are very inexpensive, simple, with less number of instructions set to process, and they are RISC architectures. This is all about the difference between microprocessor and microcontroller. Now we will have a introduction to ARM controller. ARM stands for RISC machines, advanced RISC machines. The microcontroller is a single chip computer with all the peripherals like RAM, ROM, IO ports, timers, ADC, that is analog to digital converter, DAC, digital to analog converter, at the same chip. Nowadays, different types of microcontrollers are available in the market. Some of their examples are PIC microcontroller 8051, ARM microcontroller. ARM stands for Advanced RISC Machines. AVR, MSP, depends upon the specific applications. Now we will have features of ARM processor. ARM processors are having load and store architecture. Load and store architecture means they are not having accessing directly to the memory data. Everything is loaded from memory into the register. After execution, the results are stored back into the register. That is why it is called as a load and store architecture. Register set available in ARM processor is of 32-bit size. Every register, it is having length of 32-bit. And instruction set provided by the ARM processor is same for all the instruction. They are not variable instruction set like microprocessor. So instruction set instruction length is again of 32-bit. Then maximum instructions can execute in a single clock cycle. That is very main advantages. They are energy efficient, as they are having power saving mode offering to the users. They are having two instruction set they are using. First instruction set, that is of 32-bit, that is called as a ARM instruction set, and second instruction set is called as a thumb instruction set, that will be of either 16-bit or 32-bit. Some of its example is JSON instruction set will be used for Java programming. And older cores have a 16-bit instruction, while current core are all having 32-bit instructions. ARM processors are using three-stage pipelining, and that are having three stages as fetch, decode, and execute. These are the three stages in the pipelining. They are having very simple addressing mode and simple instructions, as they are RISC architectures, reduced instruction set computing, and every instruction can be a conditionally executed. Means one instruction you are taking, then it is having condition checking along with it. ARM processor supports three data types. 8-bit data type called as a byte, 16-bit data type it is called as a half word, and 32-bit data type it is called as a one full word. Then ARM processes instruction it is executing that contains the three operands. We can have this example C add R0, R1, R2. That instruction consisting of three operands. Two operands are for source and one operand for the destination, where R1 and R2 in this example are the source operand and R0 is the destination operand. What is the meaning of this instruction is content of R1 and R2 register will be going to be added and its result is loaded into the R0 register. So this is all about the features of ARM processor and thank you for listening. Have a nice day.